Hello everyone, welcome back to Structure. Today we come back to steel billboard advertising. Now let's focus about foundation design. You can check my tutorial in my channel about how to design steel billboard from the head footing to the upper element, and also about how to design foundation. In the case we focus about wall pile foundation or single wall pile. You can check in my tutorial in my playlist. I post this video on February 11, 2022. You can check on my channel about how you can design rebar in wall pile. There are three parts: part 1, part 2, and part 3. You can check about the concept design manually and how to verify it in Excel. We follow with the design code ACI code BS8110 and CP4 or Singaporean standard. For upper structure or this TV board, you can check from the tutorial. There are 4 tutorial. The tutorial is complete tutorial 3 for foundation and for the upper structure. In this tutorial also tells you how to design from the head footing to the upper structure. You can check. Now come back to structural plan. This is the structural plan in steel billboard advertising. I showed you in a previous tutorial about explain you some component on this structural plan and about foundation and about how to arrangement rebar in foundation, pipe cap, and also design connection, structural connection. And now we focus about the foundation. Let's go down to the foundation. The detail wall pipe. We use the wall pipe foundation 1.5 diameter, and the main rebar is 15 dB25. The stirrup we use diameter rebar is round bar 8 mm, spacing 150 mm. The ball pipe dip is minus 10.1 if we compare with the 0 top level. This is the embedded length into the soil. At least we need embedded length 9.00 for design this type of structure. Receive very large lateral force and small applied vertical load. Now we need about the data to compute to verify it manually. To verify it manually or verify it in software GEO5 or software Geo analysis. You can check both software or use plastic. Now in the case we will focus about software foundation analysis, and we will concern about displacement. You cannot ignore displacement. We have displacement at the foundation, and the one is displacement at the upper structure. Upper structure also has its own deflection. When we design, we consider it a backfitch. Backfitch, no deflection at the base. It design a fitch. In the case I will explain you snipping tool, screenshot. We design it as the fitch base. Okay, fitch base. This one is like a fitch support. Fitch. We can design like a cantilever column. In this situation, you see at the base, at the level or 0, we consider it no deflection as support. So after you run analysis and design at the top, you can check in my tutorial about the analysis and design result, about the moment, shear force, edge visibility, earth ultimate, and about the deflection in both directions. You can check here. I want to explain you. It's around 60, okay, 60 millimeter maximum deflection at the top. If we compare from the back is 0 at the top. The maximum deflection is 60 millimeter. But in the case you can check in the soil analysis result. Now come back to geo analysis. You see here the displacement at the top of the pie cap is minus 34. So what does it mean? It's not fit at the back. The case is a pie. Example, I draw it in a schematic view, not a realistic. And this one continue to we consider it deform linearly. In the case it deform like this one linearly. It has to be bought. So it's not 0 anymore at this location. You has one displacement from the foundation. I call it one displacement, and this one is second displacement. So if you compute both displacement, include the displacement of the foundation and displacement of the top panel, okay, or the top panel of the steel board advertising, the maximum displacement is not 60. It will be increased. I just say 100 millimeter. Okay, you can estimate it. Indicate. You see in the analysis and design result. You see here the estimate displacement, lateral displacement is minus 34. We can say 35. Okay, 35. You can use it to predict 35. If you can continue it, so displacement at the top will be increased from the initial value when you design it at the west connection. Don't forget to include both effect or the foundation displacement include with the panel displacement. I call it panel displacement. It at the top, or upper structure displacement. It is very concerned for the single pipe. In the case we tell you how to analyze this type structure in geo analysis. Now let's come back. Okay, if you want to know about design this structure, you can check it. And for steel connection at backplate, and this one for concept from beginner, and you will got more information and concept about how to design rebar in a concrete bore pipe. It is very good and comprehensive with the reference text. You can check. Now we focus in software. After you open software, you create new model. This software will show you about the project. The project you can input the project name, project part description, customer. We now focus about the system or unit. In the default software, this software we use the default unit is English. English is imperial unit, pound, input, keep. I don't want to use this unit system. I want to use SI unit system. So you just click on the metric and click OK. You see the unit weight of the water considered is 10 kN per cubic meter. so it's the SI unit. If you use the English unit, the unit will be changed to pound to inch. I don't like this. Now we want to use a metric unit. Okay, after you click on the project, you click on the setting, and the setting you can edit or add. Okay, add, or you can select setting and you select the standard you want to use for analysis and design. You can design according to ACI code, or you can design stability. You can verify and check with the method and settlement, also which one method you want to use, pi CP or pi. You can check it. Now we use this method: Thomson linear polo elastic subsoil PY methods. And now just click add. If you do not add this method n is a zero code, you can design according to the ACI code. Now after you n, I can add. After you add, you can click on it and you can add to administrator. You can edit it. Okay, you can edit it. You see here, this is the method, and you can change it. Now click OK. We click on the profile. This is the important part. You have to assign the correct soil data if you want to calculate actual about bearing capacity and soil settlement. Now in the case you can add soil. Okay, add soil, add coordinate. Now I add it 10. I add already 10. Now you can edit it and also remove it. And terrain elevation, because the terrain elevation is 0. And continue to modulus. View is constant. You can select the type or the modulus or subscribe reaction. And soil, this part is very important. You have to add soil. You click on soils and add. In the case we only consider one soil layer. I don't want to input multi-soil layer because it's a similar soil layer, so I assume it the one layer. In the case you can change the color. Okay, color type you want. This one is the hatch color, is the same with we use it in the current color. And this pattern is the geo, you see. And the basic data, you can input the correct basic data: internal pressure, internal friction angle, coefficient, or Poisson ratio, or odometric modulus. And for the displacement angle, the angle is around friction angle, so friction angle divide 4 to the maximum is the value of soil friction angle. And you can add it, or you can click on classify and import soil from the soil library. Okay, in the case if I want to use this soil layer, you can import it and you can change the parameter and assign it. Okay, because I assigned it already in this soil type. And after you classify from the soil library, you can click OK, assign. The soil will be assigned to profile automatically. If you OK, you have to assign it one more time. Now click cancel and click add. After you classify it and you click add, the soil will be add in this profile. Okay, now continue to assign. After you define soil layer, you have to assign soil into this soil profile and loading. loading, you can add new load because I has a civil load already. You can include on edit. In this parameter or load, you can change the load combination or load title. Now I want to keep it in default. Now input the value or the reaction. You can check in my tutorial about the steel panel, steel billboard advertising. We got the reaction at the base from the model, as you can check, but in the case I shall input in the not accurate value. I remember the value, I shall input it not accurate. For more accurate value, you can got from the model. This one for the axial force, we apply in 150. It's mean in compression. The gravity load is direction of gravity, and bending moment we apply as squeeze, and in both direction X and Y, but you can consider the right direction, but it can actually input it. So you can input the similar value, and horizontal force also for the calculating the shear stress, and for the calculating of the shear bar. And in now you can design in a circuit, or you can design it. It's similar result if you use this circuit or the design. You can check it. Now I want to design it in service. If you want to design it in Ultimate, you can apply the load and moment in Ultimate. Now I want to use a circuit load to design. Now click OK. And after you input the load and geometry, this software asks you about basic dimension. You want to calculate on the circular section or what type section, I section, pi section. Now we want to use in the circular section. You can check about our pi profile. This one is the ball pies with the diameter 1.5. It's round section. So we use the round. Okay, round section is correct, and diameter is 1.5. And sorry for my graphic is not fit with this software because I use MacBook Pro. It's not support with the graphic. For your PC is not the same issue with mine because you use Windows. So the pi length, you have to input the pi length is 10. See here 10. The soil is 9. Okay, 1.2 from the soil to the top pi cap. Okay, this one is 9. Okay, embed the soil is around 9 meter. So you have to input the correct with the same as with the real structure, because your structure you have soil, and also soil you have pi cap. This type pi cap is the free earned, not fixed earned. So you design it with the same as possible as with your real structure. And the pi height offset, this one is 1.2 pi height offset, and dip or pi height offset. And now after you complete this parameter, for the closest node parameter you can input or analyze. I take an analyze. And technology type, you can select the technology of your ball pie, and type of pies you can select it to continue or file or curve pie or user defined. Now click on the material. This material we use concrete material for the ball pie. You can check for the timber or for steel, but in the case we use concrete, you can check about the note about the GEO5. We use 390 megapascal, and for the concrete cover we use 8 centimeter for ball pipe, and concrete strength we use concrete strength SCU 37 megapascal. All cylinder is around 30 megapascal. And after you got the information, you can input it. And how to determine the value of the concrete strength, you can check. Okay, why we use the concrete strength, you can check with my tutorial about how to design ball pipe. The tutorial shows you detail about how you can choose concrete strength in your project, in your foundation design. You can check here. I talk more in this tutorial, and you can collect more good information from this tutorial. Come back and check the 3 tutorial again. Now continue. And the unit base of the concrete, you can input it 23.5 or 24 or 25. And catalog you can use in the catalog. Okay, default catalog for concrete, you can select it. Now we use the limit only 30 megapascal for the cylinder strength, and you can use user define. You can define your concrete strength if you want. Now in the case I keep in the default, I keep use the material from the library. And for the longitudinal rebar, you can use catalog, or you can change it user default. In the case in the catalog, only 3 steel strength available. For the gear strength 420 megapascal and 500 and in design strength library all available for 3 strength. The first is 420 megapascal, and the second is 500 megapascal, and the last one is 550 megapascal. It is a high tensile gear strength or rebar in the European country, but in my local country available steel gear strength is you can use the user define. After you use this user define, you can change its name. Now I use this name B390 and input the gear strength and okay. Now continue to water level. Is in this structure contain water level at any level, you can input it. Now I input in 5 meter below the soils. And negative skin, if you want to include negative skin friction, but okay, I don't want to include. And state setting, we design it permanent. And vertical cap, in the case you can check draw limit loading curve. Limit loading curve according to the settlement. We use the maximum settlement of soil is 25 millimeter. Okay, you see the graph ultimate load transfer curve, and this graph the axis is for the settlement 5, 10, 15, 20 and 25 millimeter, and plot the load according to the graph. You can determine the load 25 and with the load 496.67 kilonewton. Okay, and click on the horizontal load, and you can check support condition fixed at base or free at base. In the case we do not use free base. What type of base? According to your structure, you have to classify your structure, because in the case we do not has beam, okay, we do not has beam to fit or floor to fit at the top. So this soil is this level, at this level soil. So we know other upper structure to receive this pipe cap. Okay, this pipe cap is free. So let draw displacement is larger than fit base fit at the top. If you this function which at the top, the displacement settlement will be smaller than the free. Which one is correct with your real model? You should select this type. Do not you fit or you free, you fit or you free, but you don't know when to use it. In the case, you have to know about your structure, about its behavior. It has a restraint at the top, so you can use it different way. But in the case, I'm sure our structure is free at the top of the pipe cap, so we use free pipe cap. So the displacement is as the result of this type of analysis. And for the rebar ratio, you can design it according to column, to beam, or to pipe. But actually, in Zero code, you can design as pipe. The pipe, the rebar reinforcement is lower than the column required. If you use the same with column, the percentage required for the column, for the minimum in column, is higher than for the pipe, because column no restraint surrounding by the soil spring, no restraint to against the lateral displacement. But for the pipe, we include the soil substrate reaction to reduce displacement. It also designed as the restraint. And you click on the pipe reinforcement input. This the profile is the diameter of rebar. Now come back, check the diameter rebar is 25. Diameter rebar, input 25, and the number of rebar is 15. Okay, is 15. Is correct? 15. And the cover is 80. Is correct. And shear reinforcement we use H millimeter and spacing 150. Indicate this rebar use the same strength with the main rebar. You can check it manually in different case when you use the lower steel strength. But now we not focus much about shear reinforcement. In this section, only the concrete and the main rebar can resist shear reinforcement. So for more detail, more focus, you can check again and again with my design. Explain you in the 3 part. You can check it. Okay, now you see here the bearing capacity of pipe in shear is only 20.8%. The bearing capacity of pipe bending, again bending and compression, is the combine of the bending moment with the compression force is around 80%, and the reinforcement ratio certified 3 is 60%. You can verify with in both direction in Y, in H. Okay, in each direction is the bending with the compression is only 8%. Now you can verify in direction of maximum effect. We don't care much about which direction is higher value or design control, you can use the maximum value or those two axis. Okay, this one you see the axis control is the Y. Okay, let's select on verify in the direction of maximum effect. Okay. Maximum effect, you can check it in detail. The maximum internal force and deformation, maximum pi displacement is around 35%. Now let's check. If I consider this pi as a cantilever 9 meter, I use the allowable settlement is 150. So the allowable settlement for the pi is around 60 millimeter, and the maximum pi diameter, maximum pi displacement is around 35, so it's below hash or design limit. It's okay. And for the maximum shear, maximum moment, you can check here the maximum moment at the location, and dimensioning or reinforcement. Okay, you can check the design ratio we provide is around 0.4% rebar, 0.41%. Okay, the value is greater than the minimum reinforcement for this ball pie, so it's okay. And for the load, we apply load 13 tons in compression, and bearing capacity is around 16 tons. Okay, 16 tons. Then you can compare it. Calculator. Now I shall compare it. 13 tons and 16.5 tons. So in compression it's work around 80%. Okay, it is very good result. We use this result to result around 20%. And okay, for the moment, you can check for the moment. Calculator and moment 1353.88 is the applied moment, and this one is resistance. You can divide by 1722.04, so it's around the same 80% for the bearing capacity. And verify shear is okay. Now verify ultimate shear is okay. After you complete analysis and design, you can seal it, and you can click on print document, and print document. You can view and the whole page, and you can scroll to maximize this page, and you can view it one by one. Scroll down. Okay, scroll down. This last page is a summary about displacement, shear, bending, and modulus of soil. Modulus of soil, we use the constant modulus of soil. And in the page is a summary about design, maximum force and deformation. You can check here, and with design ratio. Now after you complete analysis and design, and you know how to use concrete strength, you can check in my previous tutorial in YouTube. You can check it, and how to design the upper structure, you also can check from this YouTube channel, and you got more information about how you can design and how to know about your structure. Okay, I want to talk again about the deformation when you use the fixed base design. Okay, fixed support, and this one is the relative deformation compared with zero, because at your base is zero, no deformation when you use fixed support. But actually, when you design with ball pile, your structure is working together with ball pile and with the steel billboard advertising for the upper structure, so it will work against wind load or against lateral force. So this structure will be deformed together. So in the case, we might concern about the deformation, include deformation of the outer foundation and upper structure deformation. So we consider all the two deformation, foundation one and deformation of the foundation, and second deformation of the upper structure is the deformation of steel billboard. So to make sure when you design is around 60, but actually if you in a city, it's over 60, it's nearly 100. So if you compare with the allowable deflection, you will know the value is acceptable. Okay, now let me check spot check about the overall height is 18.76 meter. 18.76. Now for lower bore displacement, I take it 150. You see here the maximum deflection is 125 millimeter. When you design at the fixed base, okay, fixed connection or fixed support, you see the maximum deflection only 60. So you say, oh, it's a very good design, so it's acceptable, and you can minimize it by using this tube is smaller and smaller and smaller. In the case we use this tube is 1.2 meter. You can minimize it to 0.8 meter. It also pass. Yeah, it really pass. It really pass for the section design. It really pass, but it's not acceptable for the deflection. When you fit deflection, fit base and compare with the deflection of the top and the bottom, you will see the result is acceptable, but you do not consider with the deformation of the foundation. In the case you include the deformation of the foundation, okay, the deformation of the foundation, you see here the value of deformation is around 35 millimeter of the top of the base when you design your foundation at the free earth, not fit earth. So you include the deformation with your upper structure. After you revise this analysis and include the deformation, you will got accurate deformation at the top structure or at the upper structure. I hope you understand about what I try to explain you. Hope you enjoy my tutorial and about how you can optimize this section. Not only focus on the section design, on string design, also focus about the deflection control. Deflection control is not only you compare with at the base, because is your base is fit base, no displacement. It's not the same with the real structure. So you must to consider much about the real structure. If you can design nearly actually the value or the real structure, or consider as the can design as the real structure. It is very good concept. Now I hope you to enjoy my tutorial. Thank you.